Welcome to our last lecture of our 5.5 and also the last lecture of Chapter 5. We're going to complete this 5.5 as we touch on two more groups of formulas, one being our half-angle formulas, and on that next page we're going to find a way to convert from products of trig functions to sums and vice versa. So first thing, as we look at our half-angle formulas, we see for the sine and the cosine case, we get a little bit of an option of it being positive or negative. Now, that doesn't mean we're going to be using both at all times. What it does mean is we need to be choosing that positive or negative value based on what quadrant we're going to be in, just like normal. So we have either it's positive or negative, and this is based on the quadrant of the angle u over 2. So say this u over 2 gives me, like number 1, 150 degrees. Where's 150 degrees? Well, that's in quadrant 2, and cosine is negative in quadrant 2, so it would hold the negative value. However, besides that, we're just doing straight substitutions with these formulas. A little bit might be weird as we start with this half-angle stuff of how do we create them, but besides that, once you get it started, it's just a plug and chug at that point. So, looking at number 1 and number 2, you guys will be giving number 2 a shot after we knock out number 1. For number 1, I want to find the cosine of 150 degrees. Now, we could look at the unit circle and we may know what the cosine of 150 degrees is. But just to show a nice example of when we do know the value so we know what to expect, here's how we can use our half-angle formulas to find the cosine of 150. So, cosine of 150, what's a way to get 150 after something being cut in half? Well, we know that is the same as cosine of 300 divided by 2. Now again, we know cosine at 150, that's on the unit circle, no big, but this is a good example for when we do number 2, we don't necessarily know values at 105 degrees, but when we double that and divide it by 2, we do know values at 210 degrees, so we can use that known value. Let's continue with number 1. So we're going to use our half-angle formulas. Cosine of 300 over 2 is cosine of 150. We know 150 degrees is in the second quadrant, so this is going to be negative when we use this formula up above of 1 plus the cosine of 300 divided by 2. And again, we know cosine of 300, that's just straight from the unit circle. So this is going to be negative 1 plus 1/2, so there's our cosine of 300, divided by 2. And then we just continue kind of solving this out, right? So we get our common denominator up top. That's going to give us negative 3/2 divided by 2. And then we'll multiply by the reciprocal, and we'll end up with negative square root 3 divided by 2. Which again, if we look at 150 degrees on the unit circle, we expected this to be the case. Now this is just a nice little example. You guys are going to give it a pause and give number 2 a shot. And we'll just start it off just slightly together. To find tangent of 105 degrees, which I may not know, I can use this half-angle formula up top, and I can use the fact that I know the tangent of 210 degrees. So regardless of which of the two forms of tangent I pick from, I can always pluck out the cosine and the sine of 210. So give it a pause, give it a try. We'll come back to number 2. Coming back to number 2. So again, we're trying to find tangent of 105. We're going to use our half-angle formula. So that means we get to rely on our knowledge of tangent, or in this case also cosine and sine of 210 degrees, which we do know from the unit circle. I chose this first version of the formula. Either version works totally fine, always the same answer. However, sometimes considering the situation, one form might be better than the other. But I chose the first. So we get 1 minus cosine 210 divided by sine of 210. And then again, at that point, we're just doing substitutions of our known values. The 1 stays, the subtraction stays. We know cosine at 210 degrees is negative root 3 over 2, so we make that substitution. Then we know sine at 210 is negative 1/2. We make that substitution. At that point, we're just cleaning up this fraction. Common denominator is up top, add it up, and then we'll do keep, change, flip to get our final answer. But again, just like with 5.4 in the first part of 5.5, every time we're working with these problems, you're kind of already being informed that you're going to be using one of these formulas. So if you're not using it or don't know where to start, this is always a great place to start. So that's our basic use of the half angle formula, just to find an actual function. Now, like with the rest of everything else we've been doing, we're going to take these ideas and apply it to solving some trig equations. So again, with solving trig equations, we have one of two cases. Either we want the answers from 0 to 2 pi, so a finite number of answers, or we want those 2 pi n multiples, but we're going to be avoiding that here because we want just answers from 0 to 2 pi. So again, looking at number 3, we may not know exactly where to start. However, right away I'm seeing a half angle, sine of a half angle. So just like with double angle from 5.4, anytime we can, we want to use those formulas to get everything in terms of either just cosine of x or sine of x. So I'm going to make some substitutions of the sine of x over 2 from our formula up top, but just remember that that's going to be squared afterwards. So we have cosine squared x on the left. We're not sure quite yet, plus or minus. We'll see where this isn't really going to have an effect right here. So here is going to be our formula for the sine of x over 2. So 1 minus cosine x all over 2, but again, that was squared, right? So we're changing this form and we're squaring this. I'll make this squaring just a little bit darker. That's going to be a key thing we come back to. So from there, when we square it, it's going to get rid of this plus and minus because it's going to get rid of that square root. So in that same motion, I'm going to clear that denominator over. So I'm going to multiply that 2. And now, more or less from this line, this is something we've already been working with before, right? Get all the cosines, get everything onto one side. It'll be quadratic in form. We can factor and solve. So that's exactly what we're going to do. So we have everything onto one side. We can factor this. That's 2 cosine x minus 1, and then cosine x plus 1. You could set each equal to 0, solve for cosine of x. So we want to know, where is x going to be equal to 1/2? Or where is cosine of x going to be equal to negative 1? Well, if we use our unit circle, we sketch it out. We know for cosine of 1/2, we're going to get that at x equals pi over 3 and 5 pi over 3. And cosine of x equals negative 1 at pi. Oops. There we go. Now, there's an extra little thing in this problem I've yet to touch on, and that is this phrase right here of checking for extraneous solutions, either with a graph or algebraically. And what does that mean? That just means for an extraneous solution, we need to double check, considering we did a really hefty change on the original problem, that these 3 solutions still work. Now we can do this one of 2 ways. You can look at a graph, or we can just check these back with the original equation. And our reasoning for this is because when we squared this value that was potentially holding both positive or negative solutions in there, we kind of remove the possibility for anything of that negative solution. So with these, when you end up doing that, you just have to double check that one of these answers wasn't kind of produced by accident that doesn't fit with the original. Well, lo and behold, whether you look at a graph of the original equation or you just plug these 3 values in separately for x into the original, we're going to find that all 3 of these work. And more often than not, we'll find that all of those values are working. So similarly, you guys are going to give number 4 a shot. And as a good starting point, we have cosine squared of x. We have 4 times sine squared of this x minus 2. So I want to start by manipulating that sine of x divided by 2. So give it a pause, give it a shot, get as far as you can, and just remember at the end to double check your solutions back in the original. As we come back to that number 4, again, we're making that substitution of the sine of x over 2. That's what we have happening right here in parentheses. But just like number 3, we end up squaring that. So we end up changing the signs of our possible solutions. So for, again, that reason, we need to check our final answers to make sure they still work in the original. We're not producing something extra. But once you square this, I also clear the denominator, so I'm multiplying everything by 2. And from there, we end up with cosine squared x plus 2 minus 2 cosine x equals 1. We get cosine squared x minus 2 cosine squared x plus 1 equals 0, right? So we're just shifting our way to working with this in a quadratic fashion, like the majority of these equations. We get repeat factors, so we only have to look at one of those, where cosine of x is equal to 1, and that's exactly where x is 0. Now, just to be sure that this is an answer to the original, because even though there's only one answer, could have by accident been produced when we remove these signs right here, we do plug in 0. Cosine at 0, well, we get 1. We square, we get 1. Sine at 0 over 2 is 0. You square that, that's 0. Multiply it by 4, that's 0. We end up with 1 equals 1, which checks out as a possible solution. So just like we did with 5.4, in order to sum of 5.5, you're always utilizing that formula kind of at the beginning. But more or less from that point on all these equation solving problems for trig, the rest of it is pretty much the same. We're either working towards a quadratic form for factoring, or we can factor it through another method. But from that point on, it's kind of the same thing, rinse and repeat. So it's just that initial piece that we're using these formulas in to change it. Now that wraps up the more technical stuff from the last of this 5.5. On the last page, we're just going to see some ways to change from some products into some sums of trig functions and work our way back from that. As we get to that last page, we look at the top and you see a slew of formulas. And once again, these formulas, we're not stressing the memorization. It's all about identifying which one to use and applying it. So I would absolutely be keeping this handy as we're doing work. And those two groups of formulas we have are when we are viewing some type of product of trig functions. So for example, number 5, I see a product of cosine times sine, and being able to rewrite that as some type of sum that's happening. And then even within those sums, if we needed, we have formulas for those as well. Now, we're not going to be doing extreme manipulations and stress a ton of equation solving with this. That just adds a bunch more layers, where it's more about identifying again, and then being able to apply that to a given situation to manipulate its form. Well, right off the bat, looking at number 5 and 6, we're looking at product to sum. So we're already letting you know we're working on this first group of formulas. And for number 5, I'm looking at this product, and the form will matter. I'm looking at this product of a cosine times a sine. Well, here's a cosine times a sine. So I'm letting u be 5x, v be 4x, and I'm just making substitutions into this formula. Nothing crazy besides that. So we get this 1/2 outside, and we get sine of u plus v, so sine of 5x plus 4x. And then we're going to subtract sine of that difference. Again, we're just working on simplifying this and manipulating it. 5x and 4x, that gives us sine of 9x. And 5x minus 4x, we get sine of just x. And as a final little step, just to kind of separate these two so we can work with them separately, say in the future if we needed to, we just distribute that 1/2. So we'll end up with 1/2 sine of 9x minus 1/2 sine of x. and not a ton more behind that. If we were at this point, technically we've worked with some stuff like this with solving equations, which is always kind of that end game, and we could take it from there. But for now, we're just stressing recognizing the form, knowing the formula to use, and working through those manipulations. Now, we're going to go down to practicing a sum to product problem. And then after that, number 6 and 8, you guys will give it a pause and give those a shot on your own to see how you're able to do with it. So I'm going to be moving down to number 7, where I'm given a sum of trig functions, and I want to use one of the formulas up above to kind of rewrite its form to kind of help me find that value. Now, again, we may not know the sine or the cosine of those values given. For example, 105 degrees, we may not know the sine there, although with the half angle stuff on the page before, we could use that. But we're going to see with this sum to product, with a sine plus a sine, that's our very first one up top, we're going to let u equal 195 degrees, v 105 degrees, and we're just using this top formula. So we come down. This is going to be 2 times the sine of the sum of these two angles divided by 2. So 195 plus 105 divided by 2 times the cosine of their difference. Now, right off the bat, that's not too pretty, right? But let's do some simplification. We may see some things start to pop out that we're used to. So we have this 2. 195 plus 105 is 300. We divide that 2, and we get sine of 150. Well, 150 degrees. We know that on the unit circle, so that one's nice to work with. And then cosine, we look at the difference of these two, and we're going to end up with 90 degrees, but we divide it by 2, so that's just cosine of 45 degrees, which again, we know that value. So at this point, we're just making those last little bit of substitutions. We know sine of 150 is going to be root 2 over 2. Cosine of 45 is also root 2 over 2. And like we're seeing in 5.4, that last little bit of simplifying, multiplying these fractions out, we end up with simply a square root 2 over 2. So we're recognizing which form it is up top. We're just making those substitutions into these formulas. And as you're going to find, lo and behold, we'll probably be given some values that we actually can work with so that we can finally solve those. So give it a pause. Give number 6 and 8 a shot. The first, number 6, is talking a product to a sum using that first group of formulas. And that number 8 is doing a sum to a product using that second group of formulas. Recognize, translate that formula down, make those substitutions, and then it's just some simplifying after that. As we wrap up this 5.5, we're looking at number 6. We see we have a sine times a cosine. And as we look up top to those formulas, that's that second to last formula we're going to be pulling from. We're going to be letting u equal 7 theta, v equal 3 theta, and this entire time we also have this 2 floating out front. So this is something we're going to touch on a little bit right now. So as we work this out, we're just doing that substitution, right? So 1/2 sine of those added from right here plus sine of their difference. We end up with 1/2 of sine of 10 theta plus sine of 4 theta. And then we would quickly scribble down, right? 1/2 of sine theta plus 1/2 of sine 4 theta because we just did that distribution. But the thing I did leave out is that little extra 2. So when we're doing those formulas, they're only applying to the exact function themselves, which means it's really easy just to dive into that formula, plug it down, rip through it, and forget some of those details. And the detail here being is that we multiply everything at the end of this by a 2. Well, 2 times 1/2, we just get a 1. So that just turns into a sine of 10 theta. And that's going to happen for this one as well. We just get a 1. So as we're doing these formulas, make sure you're really paying attention to those details. As you've seen, brackets and parentheses to separate stuff is always going to be helpful. Now, lastly, looking at number 8. Number 8, we're dealing with the sum of 2 cosines. And this is going to be that second to last formula up top on the sum to product. And where we don't know much about pi over 12, 5 pi over 12, and the cosine at those values, when we use that formula, for the first, we end up with a 6 pi over 12. And here we end up with a negative 4 pi over 12, and then those both get divided by 2. But when we do that, it translates to stuff that we've been using a ton of, right? So we end up with cosine of pi over 4 times cosine of negative pi over 6. Or another thing to call this would be 11 pi over 6, the same trig values, right? And then that whole thing multiplied by 2. Well, it's that 2. That cosine of pi over 4 is just root 2 over 2. Cosine at 11 pi over 6, or negative pi over 6, same thing, is the root 3 over 2. And we're just multiplying everything across, and we end up with root 6 over 2. Now again, we're only using this for some manipulation for now to change its form, but we could use these formulas and techniques with solving equations, so keep that in mind in the future.